I started thinking about this problem in about mid-2012, and there was prototypes in around about late 2013. So it's been a long time coming. So I just want to start by acknowledging, but by mentioning that, but also acknowledging the efforts of other people, in particular Andres and Heikki, who some of you will have seen at the South Bay meetup that was on recently, where Heikki discussed the PG Rewind utility. Anyway, okay, so I'm going to talk about what the feature actually is. It's about inserting or updating a row. It's inserting a row, or on the basis of what you might consider to be a duplicate, an equivalent row existing, updating it instead, reconciling the two because you were unable to insert. I have a particular idea of what it ought to be, which might be over and above what other people would consider it to be. Specifically, I think it's important, and I believe this view is widely shared, that it be as simple as possible to use, and that to as great an extent as possible, it's something you can use without giving too much further consideration to concurrency issues, race conditions. Certainly, in general, not over and above what you would give to, say, an ordinary update in recommitted. I'm equivocating a little bit, but basically what I'm saying is that you don't have to think about concurrency because we thought about it for you. So we're trying to avoid various classes of errors here. I have this term I use occasionally, the fundamental Upsert property, which is just this idea. And in particular, I want to avoid these things. So I don't think it's okay if you're upserting and then at random two upserting sessions deadlock, even though there's no user visible mutual dependency. This is something I call an unprincipled deadlock. I also don't think it's okay that they just randomly throw a dupe violation just because of some implementation restriction. Again, it has to be as easy to use as possible. It ought to be possible to write an upsert and then put it in your application and more or less leave it at that without being an expert. And so the way that this more or less implies that it has to be driven by an upsert. In other words, I have to make it something that starts with an insert and then goes to update in the event of encountering a would-be duplicate violation. Otherwise, there are problems basically with ensuring that those other properties are maintained if you do it through any other approach, except perhaps locking the entire table, but that's not going to fly. So it's very useful for OLTP web apps. This is a feature that a lot of people have been looking for a long time. It's going to be in Postgres 9.5. I'm very happy about it. So let's take a look at the feature. A little bit on the syntax here. These are 3 example statements. The first, this should be fairly self-explanatory. So you're inserting, or rather proposing for insertion, these 2 tuples here, these 2 rows. And then in the event of a violation, you're going to update rather than insert in a way that's more or less equivalent to being able to, in this case, more or less equivalent to being able to successfully insert in the first place. Similar idea here. This is showing a predicate limiting where the update affects the row. Here we see something which is not really an upsert, rather it's a insert ignore type statement, which is also in 9.5 and has similar infrastructure internally. So we're doing nothing. We're not locking the row. We're certainly not updating in the event of a would-be dupe violation. So we always lock the row, even if we don't update it. So here, if this predicate were to not pass, then we'd still lock the row, which differs from ordinary updates. That is not ordinarily true. Of course, do nothing does nothing, including locking a row. So I want to talk about this here in a little bit more detail, highlighted. This is the excluded pseudotable. Now what this does is allows you to reference the things you originally proposed for insertion over here. So as each row is updated, if indeed any row is updated. The update references in respect of that tuple the thing that you originally wanted to insert. So it's a pseudotable that you can reference for this purpose. This is ordinarily convenient, but here it's essential because we've got 2 rows. We couldn't very well repeat this down here because we needed something for both rows. So this is something that we're using in these upsert statements, and you'd probably use them in virtually any such upsert. I also want to call out something that I call the inference specification, which is this highlighted thing here. This is something that allows the system to figure out what unique index you might intend to take the update path on. So it's necessary to know with some certainty what you're going to take the update path on for each row. Otherwise, you could get wrong answers. If you fail to anticipate a dupe violation in some other unique index that represents some other constraint or business rule, you're going to be in trouble when you go to update it because you'll have assumed that can occur, and when inadvertently, for whatever reason, it does occur, you have a problem. So by doing this, you are asserting essentially that you want to use the unique index, and only the unique index that, in this case, is the primary key. And if, for example, there was another unique index and you happen to violate it upon inserting, then the fact that you had indicated that you wanted to use this one would make that just raise a dupe violation, so it's safe. So it's a safety feature. It's a way of making sure that you don't accidentally get logical corruption, if you will. And this is mandatory for the upsert variant, but not the do-nothing variant. With the do-nothing variant, you could reasonably not particularly care about which one you actually get a violation in. So this is something that MySQL doesn't offer with its more or less comparable feature. So it's very forgiving. It's going to figure out for you what available unique index it should use. It'll do this it doesn't matter what order you specify. It's very forgiving. It accepts expression indexes. Now you can name a constraint directly, but I discourage the practice. It's only really useful for where you can't use the inference specification, i.e. with exclusion constraints that don't accept that. So you could use an alternative syntax, which is on conflict on constraint name. I haven't shown it here because I discourage people from using that, but just you should be aware it's there. So this will figure out one or more of what I call an arbiter index, which is the index that arbitrates whether or not this alternative path is taken. A little on explaining here. And not everyone knows that you can explain an insert or an update, but indeed you can. And what I'm showing here is explaining a upsert statement that is an insert with a non-conflict do update. I'm highlighting some of the things that are novel and unique. First one is the predicate is included here as a conflict filter. So we can potentially not update because this qualification is not true in respect of the excluded. This is a contrived example. But it's also showing you the arbiter index. In this case, it's the primary key. There are a couple of edge cases where it actually might have more than one, like if you're doing a migration or something. So the idea of making you use the specification for inference is that it's very unlikely that you'll shoot yourself in the foot, either today or in the future when things change. Oh, by the way, if you can infer a unique index, if appropriate unique index is not available, then you get an error because the optimizer says, I can't figure it out, which is a feature. Okay, there's been a lot of attention surrounding the feature. Some people have said, why don't you implement merge instead? It is, after all, in the SQL standard. Does it not satisfy your goals for this project? The answer is no. because it's not really what it appears in several ways. I don't like it because it's ludicrously verbose, but that isn't really my major problem with it. Rather, my major problem is that it isn't really, as I've defined it, an upsert at all. In particular, it doesn't guarantee anything that I mentioned before. You could very well, imagining that you get upsert type behavior as I described, you could very well get dupe violations with merge, as implemented in any system. Any of the other proprietary systems that do it. And so my sense is that would have been a mistake. People would not have been happy with that. And this more or less appears to be an inherent issue with merge, a sort of laws of physics type situation where I couldn't very well have any concurrency control mechanism that would both do all the things I mentioned, but also support a fully flexible join, because merge is about reconciling two tables. Maybe one of them is a values, maybe it's an actual table in a join-like fashion. And that's different to what I'm talking about. I'm talking about the thing being based on a would-be duplicate violation. And so this is the major difference. It would be impossible for me to offer those guarantees without locking the entire table with merge, and that would not have been very good. So I didn't do that. Someone perhaps should do merge in the future. I think there's certainly a place for it. It's just not what I wanted to do in this instance. So this kind of myth persists that it is something that you would find useful and usable for, Upsert. But I think that's no more than a myth. It's not something that the vendors particularly encourage. If you look at the documentation, it says nothing of the sort. On the other hand, they haven't actually discouraged that perception, which is a little unusual. I'm not sure why. If you go on Stack Overflow, there's someone complaining about this very issue, or a lot of people complaining about this very issue, and the solution is to use a subtransaction and keep retrying. In other words, it's pretty much the same as the classic approach to doing Upsert in Postgres manually with subtransactions, which is no kind of solution at all. It's still good for data warehousing, etc., though. So these are sort of a laundry list of things that this needed to work well with. I'm not going to go through all of them, but just to give you some sense of what we spent much of the last year or so working on, where it was necessary for me to go through a massive laundry list of existing features and make sure that what I came up with worked reasonably well with them. There's a principle in Postgres development that features have to work well together. So it was necessary for me to go through this list and, in fact, an even longer list, and figure out if everything would be acceptable from a sort of point of view of having everything be well integrated. So rest assured, it will work probably very well with your favorite feature. It's very well thought out in that sort of way, and that's part of the difficulty, or was part of the difficulty in getting the feature into PostgreSQL. Okay. A lot of effort, as I said, particularly in the past year, went into these very issues. Yes, Josh?
So if you have a where clause on the do instead,
right, I'll go back and...
then rows that don't meet that where clause are simply ignored?
Not quite. In fact, they are locked without being updated. Otherwise, we wouldn't be able to make a conclusive determination about them.
Okay. But once I commit, they'll be released.
Yeah.
Okay.
Also, they won't be projected if you have a returning clause on the upsert, because they will not have been affected rows as such. So returning will project inserted or updated rows if you use this variant. And if you don't update, then you won't see it returned, which is analogous to how it works in other areas, which makes perfect sense. But like I said, the major difference is you will still lock the row even though you won't have gone to update it.
Peter.
Yes.
Is
Harold.
it possible to specify more than one constraint in the on-conflict clause?
No, it's not. I feel that is probably something Yeah, I don't know that Andres agrees with me. He's probably going to disagree with me, but I feel that that's something that would be unsuitable for the general case. Now, it is true. He's not impressed. It is true. Well, okay. Well, I might lose that one. We'll see. It is true that you can technically. It is possible today if they are largely equivalent, which is purely so that you can deal with various edge cases. So you've got a migration, something like that. So potentially, that could show not just this one, but other ones, but only if you have an inference specification and only if they happen to be more or less equivalent anyway.
Yeah, I can see another use case, which is the do nothing path.
That's a fair point. I would agree with you there.
So I would say on any conflict, for example.
Well, that's possible.
That is possible.
That's possible.
You don't have to specify an on conflict for do nothing.
Only for do update.
Okay, that's
But I agree that it would be a useful feature. I just don't see it happening for 9.5 because, like,
I'm okay with it.
What I would agree with
us,
is
but
it would be
all
useful
work
for do nothing to have some but not all, but it, anyway. Sure. So, just to summarize what I've said, I'm a little over time. I'm very happy with the syntax. I think we came up with something really solid and very flexible, but also very safe.
And less complicated than early versions of the syntax.
Slightly.
Yes.
I don't have to have two statements.
Yes, sort of. So it's also, I don't think it's appropriate that there's never going to be an SQL standard way of doing this, I feel, because it's really the sort of thing that the SQL standards committee don't concern themselves with. They don't concern themselves with indexes in general. So I feel that it's unlikely that they would be able to ever come up with something. I might be mistaken, but I feel it's unlikely they'd ever be able to come up with something comparable to this that we could target as a standard.
They will when Oracle supports it, or DB2.
I could go into the reasons why I think that is. I'm a little late. Okay. So I think that's probably it, unless there are questions. Okay.
Did you do any performance comparisons?
Yes, I did, and other people did. I think it's in the region of 2/3 to 3/4 as fast as equivalent inserts or updates. I say equivalent, the ones that look similar. So the performance is pretty solid. Certainly not as fast as just simply doing an update, but it's certainly the performance penalty for over and above just doing an ordinary update is quite acceptable, not terribly noticeable. So I feel the performance is very good.
The important part, it's much faster than using a subtransaction.
Yes, exactly. It's
Much faster.
it's way faster. And using a subtransaction is basically intractable if you've got an awful lot of rows, because you're going to burn through sub-transactions so fast, for too long, you're going to have an issue with wraparound or something like that, where you're artificially burning through them at huge speed, because you have to have potentially one sub-transaction per row. So it's very artificial, like burn rate, by doing a lot of upserting, which of course is not an issue here. So this might be particularly important with logical replication, where you're doing this all the time. I'm out of time now. I'm sorry I've gone over time.